Today I'll be sharing with you not the future of manufacturing, but rather how can you drive the future from a manufacturing perspective. And so I'll be speaking to you for about 30 minutes or so. And at the same time, please feel free to drop questions into the chat window and I'll be answering as we go along. So first of all, how do we think about the future and how do we think about strategy? Well, this is how most of us tend to do it. We tend to say, here we are today at some point in time. Today, it's in December 2020, and we say, well, our strategy is predicated around what we've done in the past. And we'll say something like we're growing at 5% CAGR, 10% CAGR, maybe 15%. We say we have these kinds of production lines, we can manufacture this kind of product. And then we then tend to extrapolate them into the future and say, well, we'll carry on growing by, let's say, margin. The problem is, unfortunately, there's market forces. Things happen within the market that change the run rate to which we thought we were going to go. These market forces could be anything from technology, whether it's the Internet of Things, whether it's a use of artificial intelligence, or maybe it's just user behavior, or as we're experiencing right now, it's COVID. Right? And unfortunately, these forces tend to suppress us down, and we end up being in a place worse off down here than we thought we were going to be at the top over here. And that's a real challenge. What we tend to do then is we tend to say, well, to close this gap, we need to have some kind of evolutionary innovation to close that. The problem is this evolutionary innovation only gives us a 10% or 5% hit to close that delta, the gap in terms of where we actually are and where we actually thought we need to be. If we don't do this, if we don't think about the world differently, if we don't think about the run rate, and we don't think about these market forces, we end up being what I've called an analog, linear, non-responsive business of today, where we get depressed and we have to lose our profits and we gradually get squeezed out. The challenge is, or rather opportunity is, how do we think about these market forces, not as problems, but as opportunities? And we see them through a fresh lens of entrepreneurs. And we see them as the opportunities that allow us to create a different kind of business, an exponential business, one that gives us a 10 times return, not a 10% lower or 10 times lower. To do this requires us to have courageous thinking. It's only once we have this courageous thinking where we can push what we've done for many a year, for maybe even for some of us for many a decade, that we can become a digital, exponential, cognitive manufacturing business of tomorrow. And these are the kinds of businesses we need in South Africa to drive our economy and to really get us to get back to where we were in the past. And where were we? Well, back in the year 2000, manufacturing contributed 17.5%, and that's now dropped to 11.8%. Yes, our GDP has grown, but manufacturing as a whole has dropped. That's the very bottom blue line. And you can see the total contribution has dropped over the last 20 odd years because of a number of different factors I'll go into shortly. So not only has our GDP contribution declined as the manufacturing sector, but also our share of jobs has changed. Where in the year 2000, it was the largest contributor to the number of jobs. It's now the fourth, with approximately 12% of our populace being involved and being employed within manufacturing. The manufacturing sector employs over 1.2 million people, but due to COVID, and these numbers have obviously changed, between 140 and 240,000 jobs at risk due to COVID. What's interesting is when you work it into the number of employees, the number of people in the sector, the average output per employee is 2.6 million. But it doesn't negate the fact that South Africa's contribution in terms of manufacturing has declined from the year 2000 to 2019, right? But globally, one of those things is this. China now contributes to $4 trillion worth of global manufacturing pool, whereas Africa in totality contributes only 2%, while South Africa is just a fraction of that. So a lot of the manufacturing, as we already know, is being moved to China. This is one of those prime examples of market forces. But even as we go into COVID times, what we see is India and Japan are now saying, well, how do we bring this back home? How do we basically move from an offshoring strategy to an onshoring strategy? They're starting to think about that. And in South Africa, we need to start thinking about this as well, to say, how do we move manufacturing back to South Africa and reverse the trend that it has been in the past because of cheaper goods, right? But let's think about that in a different way, and I'll come to that shortly. The challenge is, one of the big areas that we see right now from the future perspective, in terms of thinking where the future manufacturing is going to be, is this role of the fourth industrial revolution. And with many of you that are dialing in today, some of you maybe started some kind of trial. You said, well, let's try something around the fourth industrial revolution. And the World Economic Forum paper says this best. It said this in 2019. They said manufacturing has experienced a decade of productivity stagnation and demand fragmentation. Thus, innovation is long overdue. Where fourth industrial revolution innovation has been taken to scale beyond the pilot phase, unprecedented increase in efficiency have occurred with minimal displacement of workers. Here's the key point. Most companies appear to be stuck in pilot purgatory. What that means fundamentally is there's a lot of manufacturing companies that try something. They try it, they launch something, but then they get stuck in this phase. They get stuck in a phase of saying, well, we have to make sure this is perfect. And they remain in this phase of pilot purgatory without scaling that beyond perhaps the walls of the manufacturing plant. Perhaps it's worse than that. Perhaps it's just an assembly line, but they certainly don't go beyond a pilot stage. And we need that to happen more and more and more. And why is that? Because the 4-hour innovations are expected to create up to $3.7 trillion worth of value by 2025. That value won't be spread evenly, of course, and it's really a question of first mover advantage. So those that act first, some of you in the room are moving now already. Those of you that haven't started moving, you have the risk of falling behind. Right? And this is really the challenge we have for us in manufacturing, is because of the way it's distributed and it's decentralized globally from a manufacturing perspective. It's not just from South Africa for first movers, it's globally. And with China moving ahead of the game in South Africa, we need to focus and say, well, how do we leverage fourth industrial revolution technologies and how to move forward from there? So the fourth industrial revolution implies there were 3 previous industrial revolutions before that. There was the first one in approximately 1765, which was led by mechanization, 1870 around mass production, the third industrial revolution around automated production, and today the fourth industrial revolution is here we are, which I'll go into a bit of an explanation around what it really means. But I went to Google and I typed in the fourth industrial revolution, and what you see from Google search trends is South Africa is the fourth country, the fourth highest country that puts in this term fourth industrial revolution. What does it say to me? It says that in South Africa, a lot of this term, a lot of the use of the term fourth industrial revolution is really jargon where it's not really understood, because it appears to me that the fourth industrial revolution has become a placeholder term for all things technology. If you're doing something innovative, it's got something to do with technology, we say it's the fourth industrial revolution. Think about how this was reflected in Parliament approximately a year and a half ago. Suddenly 4 hours everywhere. It's not just in Parliament, it's in business, it's in newspapers. And we see things like how the fourth industrial revolution is contributing to sectors like the church. Okay? And it's really becoming something that I think is being overused without a true understanding of what it really is. Here's the one kicker, and this is very, very important. If you're talking about digitization in your manufacturing process, in your plant, in your organization, if that's the big drive for you, and maybe digitization and maybe digitalization, right? The fact is you're now moving only into this. You're only moving into the third industrial age, which means you're actually stuck in the second industrial age. And this is a key piece. If you haven't really started this journey supported by electronics and information technologies, if you haven't started the digitization process, you're already behind. You are already behind, and that's a real problem. So what is this fourth industrial revolution? Well, it was a phrase that was coined by Charles Schwab of the World Economic Forum, and he actually stole that phrase from an economist a number of years earlier. But this is what he said. He said, the fourth industrial revolution is a fusion of new technologies, specifically the merging of the physical, digital, and biological realms. That, as I said before, is where the definition tends to stop. But it's much broader than this. It's much broader, and a lot of people are not speaking about this. A lot of commentators, thought leaders, are not even speaking about this, because that's mostly the what. That's the technology stack. Beyond that, we need to think about what are the business models. These business models are the how. These are things like exponential, experience, the sharing, circular economy, some of which I won't speak to you about today because of the short amount of time that I have with you. But it's really moving beyond, and it's transitioning about the what towards the how. But more importantly, why? Why is this such an important thing right now? Why in this period of time? And that's because there's a change in value systems. And those value systems are things like, how do we create systems? How do we create processes? How do we create businesses with a customer first mentality? How do we move beyond capitalism? And how do we think about the human within this? So this is my extended definition of the fourth industrial revolution. And it's not just about the tech stack. It's not just about the what, but it's the what, the how, and the why. So let's have a look at some of these things, right? So the fourth industrial revolution, some of you are doing trials within the Internet of Things. And this is why it's so important, because it's anticipated that by 2025, 5 years from now, the CAGR rate will be just short of 30%. And it's the application of Internet of Things, it's the use of advanced robotics, analytics, etc., that places sensors everywhere to create networks everywhere. That allow you to automate, to analyze everything, and significantly improve performance and customer satisfaction. So says McKinsey in 2016. And this is the reason why. From 1970 to 1990, approximately, so for 20 years, as manufacturers, we tend to say, well, how do we analyze our machines, our equipment? And that was mostly based on a reactive strategy. So once the machine breaks, we then go and repair it, right? Or once our assembly line breaks, we go and repair it. We've shifted from a reactive to a preventative strategy. But from 1990 to 2010, it was now said, well, it's not once the machine breaks, it's not our preventative, it's about condition. So it's not total failure, it's not once the machine completely breaks down, it's based off a certain level of condition. Subject to that, where we are right now, it's no longer about prevention, it's not about condition, but it's now based on equipment, IoT, AI, process environment, and operation and organizational involvement. That's the world of using data. It's the world of predictive. It's about saying, well, how do we catch the failures before they start happening? How do we determine there's a micro failure within our machines? And as opposed to stopping the entire plant potentially and losing weeks, maybe even months of production, we can determine this potential failure time before it actually happens, replace the minuscule parts, and that downtime is maybe an hour versus a month. Because it's a world that's moving away. It's a world that's moving away from remote monitoring. It's a world that's now about predictive maintenance, but very soon it's about autonomous production, where the machines are able to calibrate themselves, they're able to determine what's going on, and they're able to schedule their own calibration and fixing within time. Right? So that's the world of IoT. But what about a pure manufacturing place? So here's a picture that's something that's super interesting that I found. This is what's called an XEV. It's short for an X-electrical vehicle. That's the name of the company. This is the yo-yo car. It weighs approximately 750 kilograms, has a max speed of 70 kilometers an hour, and has a range of 150 kilometers. What's super interesting about the XEV company, or the yo-yo car, is that this entire car is 3D printed, entirely 3D printed, which decreases expenses and development time by approximately 90%. The other fascinating piece about this, and think about your company, think about how long it took for you to raise capital. Maybe it's a family-owned business, maybe you started recently, maybe you're going through a round of private equity, right? But this company raised the capital via a crowdfunding platform called Kickstarter. And how do they do this? They pre-sold the yo-yo car. They had 30,000 orders at a price of 8,000 euros, approximately 160,000 rand. And that allowed them to start the production and 3D print these cars, right? Because it's 3D printed, it's eliminated 90% of costs, lead times as well, and it can then offer several iterations because now as soon as a panel breaks, you can just print it out, print it on a 3D printer and pop it back in. Why this becomes even more interesting is the average car is over 30,000 parts. The average car is over 30,000 parts, and the average engine has 20,000 parts. But a Tesla, that's an electric vehicle that I want to speak about today, has a maximum of 20 parts and a range of what's now heading towards 650 kilometers. Right? So the entire world of manufacturing is changing. 3D printing is a world of decentralization, and I'll talk about that slowly. But this is what's coming. In fact, it's not even coming. It's here already. So what else is there? Well, AI, artificial intelligence. Now, I won't go too far into artificial intelligence because it's a huge area. Suffice to say that the majority of the world's AI is pretty much something called simple AI. It's about understanding one task and optimizing that task. The next realm above that is artificial general intelligence. That's about understanding how something works in one realm, understanding the context and applying it to a new realm. And finally, artificial superintelligence, which is the realm of Hollywood and Skynet and Terminator. We're nowhere near there. But the key piece is the majority of AI today, even in manufacturing, is what's called simple AI. And those companies that lead adoption will have approximately 122% increase in cash flow, whereas the fast followers behind them, only 10%, and the laggards will actually reduce by 23%. So AI is becoming a huge driving force in our business because it's all the way in terms of understanding uptime, it's about understanding maximizing our production value, it's all the way in terms of understanding our value chains and even downstream and upstream of where we are. So let me speak a little bit more about this 3D printer and the decentralization effect, because this becomes super interesting. In addition to the car, we know about COVID. It's been with us now. We're in December right now. It's been with us for 7 years. And globally, it's been with us for 13, 14 months. When the pandemic first started, a number of engineers from Isanova said, well, there's a huge problem. You can't get ventilators at a cost point that is sufficient. And even if you could, there's just no supply. So this engineer said, well, how do we change the paradigm? How do we think about things differently? And they got hold of this mask. It's Decathlon scuba equipment mask, right? And what it is, they said, well, let's 3D print a valve that sits on the top. They 3D printed this valve, and that allows you to convert the scuba mask into a non-invasive ventilator mask. They patented it to prevent speculation of the price, so to make sure the price is set, and then they released that design and an open source CAD design into the marketplace. The cost of this entire design, including the mask, this entire new rig, is $100 versus $5,000 and even up to $50,000, right? And so world of decentralization has changed. It's not just the manufacturing, but the entire economics around ventilators has now changed. Suddenly you used to have the chance to sell a ventilator for $50,000. And now that cost is now only $100, right? So using technology, not only is it a speed of response, but it changes the economics of the entire industry. That's what's going on around 3D printers. Beyond 3D printers, well, you may have heard of this thing. It's called blockchain. Now, I'm not talking about Bitcoin. Bitcoin that's had a run and is now sitting at $18,000, $19,000. And some of you in the room have invested in Bitcoin. I'm not talking about that. I'm talking about the underlying technology on which Bitcoin sits, which is called blockchain. Now, blockchain is an open source distributed ledger. What does that mean? Open source, which means anyone can see it, and a distributed ledger means that all parts of the transaction, whether it's a debit or credit, or whether it's a straight transaction, gets recorded into this ledger. That ledger allows transparency across the entire value chain. What does that mean primarily? Let me give you a real world example. And let me give you an example from the world of commerce. Right? So the story goes that Walmart, which is actually still the biggest company by revenue, they had an issue with salmonella. And the head of quality control walked to his team one day. He came to the boardroom and he took a box of mangoes and he threw it on the table and said, folks, we've got a problem. This box of mangoes has salmonella. And because Walmart is a pretty reasonable company and a pretty citizen conscious and not just about financial rewards, they did the right thing. They pulled all those mangoes off all the shelves around the US. They stuck them in cold storage and they waited to find out which mangrove these certain mangoes came from because of the outbreak of salmonella. And if you think about this process, there's so many pieces as part of this chain to determine where these mangoes came from. You have to determine which mangrove it came from, what kind of water, what kind of pesticides. If there was a contractor, who were they? How was this fruit plucked? Where did it go for slicing? Where did it go for cold storage? Where did it go for distribution? Finally, what was the the distribution process to the stores? Who packed it? There's so many pieces along this chain. What's amazing is it actually took them 6 days, 18 hours and 26 minutes to locate where these mangoes came from. But using blockchain technology, where every single part of the transaction is recorded, they reduced their time to 2 seconds. And the gains here are exponential. They're exponential. And in the world of manufacturing, this is all the way from determining if a car has a failure in one of the parts and it stops the manufacturer from recording the entire car line, all the way through from saying, well, we've manufactured a piece that's faulty, doesn't fit spec, or even from quality control, the manufacturing materials aren't right. But now you can determine not only where it's gone to, but what is the use case. From a manufacturing perspective, you can see here from a supply chain, AB, InBev, Walmart, DB, Ford, and Unilever are all using this. They're all undergoing some version of blockchain experimentation because for the supply chain, this becomes crucial to track not just the supply chain itself, but also the use case for the consumer. Here's just a snapshot. A whole bunch of other industries are using blockchain. And if you haven't thought about it, I'm not saying you must do it, but certainly for the future of manufacturing, or rather manufacturing the future, we have to think about the use of blockchain and how do we use it in our businesses. Because fundamentally, companies do a few things when they innovate. They tend to start and say, well, how do we innovate on our production side of the system? We tend to say, well, how do we innovate around where we can control, where we have our locus of control? And that tends to be around our manufacturing plants, around our assembly lines. A lot of companies start there and they don't go beyond the production system. The big companies, the ones that are truly pushing values, are the ones that say, well, how do we innovate from end to end? End to end, which may not include our piece. We may be a manufacturer of one part, but what's the innovation from the end-to-end cycle, including the piece in terms of where the customer is? How do they understand that value chain, and how do they start innovating around that by using some of these technologies that I've spoken about? One such company is Tesla, which I'm a big fan of, because the story is around how when they released the first version of the Tesla, I think it was the Tesla Model S, right? They used the understanding of end-to-end creation of value, customer journeys, and how do you then create some kind of value across that. And the story goes that when you bought a Tesla and you drove it in Highway 101 in San Francisco, when you went over certain parts of the highway, there were certain speed bumps. And as you went over it, the chassis of your car would scrape on the highway. All this data was aggregated and sent back to Tesla. They were able to monitor this. They were able to say, okay, cool. Based off geolocation of the car, the Tesla itself, we know that when you're along the certain part of the highway, your chassis tends to scrape. So what they did is they said, well, we're going to release a software update, and they raised the suspension of the car by 1/2 inch. That's what you're able to do when you understand not just the end-to-end logistics, but you have IoT incorporated within not just the machines and the vehicles that you have, but around something that embeds within the user experience. Now think about how this would have been done in a normal kind of manufacturing plant, a normal kind of car system, right? You'd have to record all these cars. You'd have to analyze what's going on. You'd have to manually raise every single one of these cars. But through the use of technology, through IoT and through software, they released a software update, not too dissimilar to what you would get on your cell phone to say you've got an update from our OS. That's what they did with the car. So that's the world of some of the technology pieces, but it's more than just the technology. It's really the business models. And for this, I'm going to come back to this mask where they printed this valve, the Charlotte valve that I spoke about before, because there's a business model and there's an approach that's coming across, which is called the 6Ds of exponential economy. And this is what a lot of companies go through, specifically the ones that are disrupted. Think about the Airbnbs, think about Uber, think about YouTube, etc. But I'm going to use an example for manufacturing. So the Charlotte tube, the first thing is, what they did is they came up with a CAD design. They said, well, how do we understand what is the digitization effect of this? So they said, well, how do we go from the physical product to the digitized version, the CAD model of this? It became digitized. The next thing is very deceptive, because certainly if you were the purveyors and you were the owners of those $50,000 ventilators, you'd be saying, who's ever going to use a scuba mask? This is crazy, right? So it becomes very deceptive at first. No one believes that you can replace a $50,000 machine with a $100 machine. Then it starts becoming disruptive because of the economics involved, and because of the distribution channels, and because now you can essentially go buy a ventilator from the scuba store or a Sportsman's Warehouse. It becomes very disruptive, right? It's then completely demonetized. Remember, this piece would only cost you $100 to print, but the CAD diagram was put online. There was basically no money. The cost differential between $50,000 and $100 is basically negligible. So this became demonetized with basically no money. It was completely free. It then became dematerialized because of the digitization effect. So you didn't have to go buy a gigantic ventilator. You could print this thing. The big material costs for you had disappeared completely, right? Finally became democratized, because now anyone could theoretically go find this CAD diagram. They could go to their, if there was such a thing, their local 3D printing shop. They could print the piece. They could stick it onto to the mask, and you'd have a ventilator. So these are the 6Ds of the exponential economy. And this is the same kind of 6Ds that Uber went through, that is now completely disrupted and is now destroying the taxi industry. It's the same thing that Airbnb's gone through, and it's disrupting the hotel industry. It's the same thing with music and YouTube. It's the same thing that's going on in the financial services sector. And what I believe is the same thing that's going to happen within manufacturing. 3D printers have the ability to move away from a centralized location around creation to decentralized. And there's a great quote that says, it's not a question of where, not a question of when I'm going to buy my 3D printer. The question is, where am I going to put it in my house? Right? And so the 6D effect is super important for us as manufacturers. But even from an experience point of view, and I've spoken about this from an experience point of view, if you were to plot how diverse a product is, how much the customer needs it, and how much money you can make. And at this point in time, you may be craving for something I'm speaking about right now. I'm going to talk about the humble coffee bean, right? If you extract the commodity, so if you grow that bean yourself, you can make 1 to 2 cents per cup. But if you turn it into good, you can make 12 times more. Provide a service 75 times more, and provide an experience 250 times more. The challenge is, as manufacturers, we sit here. That's the realm in which we play. We stay over here, right? We only make the good. Have you transitioned to saying, well, how do we augment our good with a service? Can we provide a service layer on top of the stuff that we make? Some of you do. But beyond that, how do you transition to an experience? That's the big question. Because fundamentally, we got to rethink the entire value chain. The old world used to be around saying this: raw materials, processing, manufacture, distribution, retail, consumer. That's the extract the commodity piece, where you make a small amount of value. That's the make good piece. That's the product or service piece. That's the experience piece. The closer you can move to the end consumer, the closer you move over here, the higher not only is the value that you make for yourself, but the more useful this is for the end consumer, right? Here's the decentralization effect. That's the role of 3D printers, where manufacturing and distribution gets now eradicated because of that, right? This is the use of data and analytics. This is why IoT becomes such an important piece. And even though I didn't speak about greening and environmental, you all know that within the realm of manufacturing, greening is such an important element to think about. Ultimately, when you think about integrating across the value chain, as the World Economic Forum says, supply integration enables process optimization through shared data science and advanced and predictive analytics. Production increases up to 90%, 10 to 80% lead time reduction, 15 to 20% increase in configuration accuracy, and 50% increase in energy efficiency. By looking beyond just your piece, by looking beyond just that, where you traditionally kind of sit, by understanding the entire value chain, these are the kinds of gains you can make. Because we've shifted away from here. This is the old world of manufacturing. This is the old world of making stuff. And it's now about saying, how do we think about the world differently? How do you do things from here, where it becomes a new entry point? And the one other final piece to think about is the circular economy, right? And that's around where not only is manufacturing booted out, but everything's now booted out and we stay over here. So even manufacturing from the realm of circular economy and the upcycle and experience economy is now changing the dynamics of the entire sector, where manufacturing runs the risk of being completely eliminated in the long, long future from now. Ultimately, what does this all mean? Well, it comes down to something pretty much, something simple that I really believe is the essence of business. It's the essence for us to understand as consumers. It's the essence for us to understand as manufacturers as we create certain things. The first is to know your magic, to know what is it that you do? What is it that makes you absolutely world-class? The only thing that you can, the thing that you can do. Sorry, Charles, we're going to have to edit that piece. I'm going to start that again. Ultimately, it comes down to this. ultimately comes down to two key pieces. The first is knowing your magic. That magic is knowing who you are, what you do, and what is that thing that makes you the world best, right? That's your magic. The next thing is to understand the consumer. What is that problem that the consumer is grappling with? What's that thing that keeps them up at night? What is that thing that if you solve for them makes their life exponentially better? And your job as a leader in manufacturing is simply to know your magic, know your consumer, and connect the two. And then move away from this old world paradigm of B2B and B2C to an H to H approach, which is a human to human approach. It's about understanding the human. It's about understanding what does the consumer want and fixing those problems from their point of view, not from your point of view. And why is it so important? Because ultimately Netflix is going to eliminate DSTV, not because of technology, but because DSTV's high prices, lack of new content, forced adverts. Uber's doing the same thing with taxis because taxis have limited access, transparency, fares, safety, and so on and so forth, right? And the challenge is this: the challenge is not about technology. It's about technology and business, but it's not even that. It's not technology nor business, but it's about not being customer centric. And so for us, fundamentally, as we go about and we think about our manufacturing business, it's no longer about saying what's right for us, what can we manufacture, what can we do as a push strategy, but it's about understanding what is the customer experience, because it's not being customer centric and creating for users that's the biggest threat to any business. So ladies and gentlemen, thank you very much for joining me. I know this has been an absolute whirlwind. It's been incredibly quickly, but hopefully I've given you a lot of thinking, a couple of frameworks, a couple of things to think about from a technology and a business point of view. Thank you very much. Please do, as I said, pop some questions and I'm happy to answer as we go along. Have a good day.